All right, here we go. We're solving for the mass of Jupiter. And what we're going to do is we think of Jupiter has a moon that goes around it. And we can use the fact that that's circular motion to figure out the mass of this thing. So since the moon is going in a circle, it's accelerating. What equation are we going to start with? We're going to start with the sum of the forces equals mass times acceleration. And what forces are on that moon? Well, we have the gravitational force. And what's the gravitational force at that? You might want to use little m, little g, but we don't know the acceleration due to gravity there. You might want to use 9.8, but that's only if we're on the surface of the Earth. So we have to use the big equation, big G m1 m2 over r squared equals m. And then since it's accelerating, what is acceleration if you're going in a circle? Well, that's v squared over r. And now we need to put in some values. The gravitational constant, what is that? Oh, we cancel masses first. What mass did we cancel? We have to cancel the mass of the orbiting object, so that's the mass of the moon. And we can also cancel one of the radiuses. Now we're looking for the gravitational constant. What is that? That's 6.67 times 10 to the minus 11. It's that times the mass of Jupiter. And then now we need a radius in the denominator over there. So what value do we use for the radius? You can look at the chart up above. And we're going to use that 23,000 or 23 million kilometers, which becomes 23 billion meters. We want to make sure we get everything in meters. And then that equals the velocity. And velocity is equal to speed. And what's our equation for speed? Speed equals distance over time. And how would we know the distance that that moon goes through? Well, that's going to be the circumference of the circle, which is 2 pi r. And what would we use for the radius? Yep, we use that value we found earlier. And how would we determine the time? Well, the chart says that the period is 736 days. But we're not done yet because we need to get that into seconds. And we know that there's 86400 seconds in a day. And what do we do with that v? Well, we bring it back over into our equation. And now we solve for the mass of Jupiter. And we multiply by the radius, the blue number there, and then we divide by gravitational constant. And when we type all this into our calculator, I would type in 2321 squared times 223.5 EE9, that's the 10 to the 9th, divided by 6.67 EE minus 11. And when you put all that into your calculator, you get 1.9 times 10 to the 27th kilograms.